have been working with coordinate graphing and just understanding how to plot points and how to read coordinate graphs, we're going to now start looking at some relationships on coordinate graphs and other applications. Specifically, we're going to look today at reflections on a coordinate graph, and we're also going to look at distance on a coordinate graph, along with a few other things. So first up, take a moment and graph these 3 points, A at 3, 4, B at -3, -4, and C at 3, -4. Then I want you to think about if you were going to add in a fourth point, where would you put it and why, and what relationships then do your points share? So take a moment, graph those 3 points, pause while you do it, and then think about where you would put a fourth point. And once you've had some thought about that, then go ahead and hit play. So check your points A, B, and C and make sure those are graphed correctly. For me, if I were going to graph a fourth point, I would put it where I have put point D. And the reason I would do that is because then when I connect the 4 points, it's going to make a rectangle. Now, that makes a rectangle, and so that certainly sort of fits, but I want to talk about those points and what relationships we notice between those points. First of all, one thing I hope you notice is that all 4 of those have the same, their x-coordinate has the same absolute value. They all have an x-coordinate that has an absolute value of 3. They all have a y-coordinate that has an absolute value of 4. That's why they make a rectangle. But also, let's look at some individual relationships. If we look at point A and point D, I want you to notice that if we compare that to the y-axis, those 2 points are a reflection of each other across the y-axis because they are at the same height, but D is 3 units to the left of the y-axis while A is 3 units to the right. So they're at the same vertical distance from the x-axis, but they're on opposite sides of the y-axis, the same distance away, but on opposite sides. And C and B share that same relationship with each other. So C and B are reflections of each other also. And then if we look at the x-axis, notice that looking at the x-axis, A and C are a reflection of each other across the x-axis. D and B are a reflection of each other across the x-axis. Now, you might be thinking that A and B are a reflection of each other across the origin, but we can't reflect across the origin because it's not a line. What we could do is we could say, well, if we reflected A across first the x and then the y-axis, or across the y and then the x-axis, then A would be at where point B is. So we can think about it as a reflection, but it's just going to be a 2-part reflection if we think of it that way. All right, now take a moment and graph 2 more points. Graph E at 5, -2, and F at -4, -2. And then we're going to talk a little bit about distance on the coordinate plane. So if you have graphed those 2 points correctly, here's where you have them. And if I ask you how far apart those points are, there's 2 or 3 ways you can think about doing this. You can count the distance from E to F, just truly count it. So start with your pencil point on E, and then count how many spaces it is to F. And remember, just like when we count in a game, we don't count until we actually move. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 units from point E to point F. Now, if we count going the other way from F to E, notice starting at F, don't count until you move. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 units from F to E. So either way, either direction you go, it's 9 units. You could also look at it and say, well, from F to the y-axis is 4 units, and then from the y-axis to E is another 5 units, and 4 plus 5 is 9. And if you think about it, that sort of ties into the 5 and the -4 that are our x-coordinates, because the absolute value of -4 is 4, and then we add the absolute value of 5, which is 5. So the total distance apart is 9 units. So whichever way you look at it, the total distance apart is 9 units. Possibly the easiest way to look at it is really to just count the spaces. So let's add another point to that set. Let's graph point G at 5, 3. So G would be going from the origin, go forward 5, 1, 2, 3, 4, 5, and then up 3, 1, 2, 3. So here's point G. And how far is that point from point E? Well, if we want to measure from G to E, we can do it a couple different ways. We can just count from E to G or G to E. So starting at E, I would count 1, 2, 3, 4, 5. It's 5 units. Or from G to E, I would count again from G, count 1, 2, 3, 4, 5 units. And again, because they're on opposite sides of the axis, I could count from G to the x-axis is 3 units, plus from the x-axis to E is 2 units, for a total distance of 5 units. And the reason why I could do that pretty easily is because if I look at my coordinates, G is at 5, 3, and E is at 5, negative 2. So because the x coordinates are the same, I'm really just counting the distance from 3 to negative 2 on a number line. That's really all that I'm counting is that distance. And it was the same thing when I was counting between F and E. Because F and E both had an x coordinate of negative 2, or a y coordinate of negative 2 rather, then what I was really doing was counting how far it was from negative 4 to positive 5. All right, next we're going to look a little bit at our axes. So I want you to take a moment, graph 5 points on the x-axis, list those coordinates, and think about what those coordinates have in common. Pause while you do it, and when you're done graphing and listing, then hit play. So here are the points that I graphed that are along the x-axis. And what I noticed is that no matter where I graphed along the x-axis, my y-coordinate would always be 0. Because no matter what, I only have to move left or right to get to those points. I don't have to move up or down at all. So in every case, I don't move up or down. So my y-coordinate has to be 0. So any point that lies on the x-axis is going to have a y-coordinate of 0. Now take a moment and graph 5 points on the y-axis, list the coordinates, and think about what their coordinates have in common. Here are the ones that I listed, and notice now when we're on the y-axis that our x-coordinate will be 0. So any point on the y-axis rather, is going to have an x-coordinate of 0 because I don't have to move forward, I don't have to move backward. I just move up or down. So any point that's on the y-axis is going to have an x-coordinate of 0. Now, interestingly enough, remember that our origin has an ordered pair of 0, 0. And that makes sense because we don't move left or right, and we don't move up or down. And that's what the 0 means. It means don't move in a certain direction. So 0, 0 would mean don't move at all. So now we've had a chance to talk about several things and patterns that we notice on the coordinate graph. The next thing we'll do after this is in another lesson, we'll look at finding area on the coordinate plane.